In this lecture, we're going to look at arrays and compare them to array lists. Since arrays are very similar to array lists, we're going to move very quickly through the contents of this lecture. In a previous assignment, we've already worked with arrays as the command line arguments that are passed into the main method are passed in through a string array. And so those brackets here mean that we're working with an array. So an array is just another type of collection. It's very similar to the array list. So we'll look at some basics regarding the array as a collection. It's just a fixed size list of data of the same type. And so this is where it's similar to an array list. We're storing a bunch of student objects, a bunch of car objects, a bunch of integers, a bunch of doubles. It's all the same data type are stored in that collection. Now it's a fixed size, and you must know the size when you allocate the array. This is in contrast to an array list, which can grow or become smaller as the program executes by using the add and remove methods. So an array list is dynamic in nature, but an array, once it has been allocated, it is fixed sized. It's a list, and it's a numbered list. Just like an array list, it's numbered sequentially starting at 0, and we access the elements in the list by their position in the list. So we'll look here at Java arrays and 3 steps to creating an array. One is we declare a variable to hold the array reference. Then we create our new array object, and then we put and get elements out of our array. So as far as declaring an array names follow the same convention as other variable names, but we use the brackets to indicate that it's an array. So here are 3 different arrays. We got a string array, my to-do list. We have an integer array, the high temps for 2011, and we have an array of student objects called CS6312 students. So this is declaring an array variable. Now, when we need to create a new array object, the previous slide we just looked at declaring the variable, but now we need to actually instantiate or allocate our array, and that's where we define the number of elements that are going to be placed in the array. So there's 2 approaches. One of these is we use new to allocate the storage. So here I've declared it, and then here I'm doing the allocation. So CS6312 students equals a new student, and here's where I'm defining the number of students I want this array to contain. Notice here, since I'm using new, that the CS6312 students is actually an object. So this is a reference variable. It is possible to do our declaration and instantiation all in the same line as is exemplified here. And then please note all primitive type arrays are initialized to 0 when you're allocated. And so if I did an int array and I allocated it to be size 10, all the values in there are going to be initially 0. Whereas if I'm doing, in this example here, it's an object array, each one of those elements is going to have null in it initially. Now another example is we can use direct initialization to create our array. So here I've done my declaration, and then in between the curly braces, I'm putting the initial values that I want into this grades array. So this is going to create a grades integer array of size 1, 2, 3, 4, 5, 6. Once that's allocated there, that's the size of the array. It cannot change over time. Here's another example where I'm putting strings in here, and then here's an array where I'm doing direct initialization where I'm putting student objects within this array here. Notice because they're student objects, I have to actually allocate my student object. So here's a new student, here's another new student. So I put 2 student objects into this array here. Now to access elements in an array, we use a subscript to get that out. And so here grades, what we call sub1, is going to get me the second element out of the array. From the previous slide, this is going to get me the value 89 out of there. The array bounds are just like an array list. They're from 0 to n-1. And if you attempt to access an element outside the bounds of the array, an array index out of bounds exception is thrown. For example, if I go grades -1, it's going to throw this exception, grades 99. And if I don't have 100 elements allocated in my array, this is going to throw an exception. Now to set and get elements in an array, the variable that is placed within my indice here has to evaluate to an integer. So here, this is going to the fourth element, grades sub 3, and this is going to assign 76 to the fourth element of my grades array. What I'm doing here is actually getting out my first element and my second element, adding them together, dividing by 2, and assigning that to the value average. That subscript, just as I mentioned on the last slide, must evaluate to an integer. So here, n divided by 2, that's 4 divided by 2 is 2. 2 plus 1 is 3, so this is setting grades of 3 and to the value of 100. When we're working with an array of objects, after allocating the size of the array, we must assign an allocated object to that array element. So here I've made a new student array, and in here, for each new object I'm going to place in that array, I must have an allocated object. So here I'm going to say a new student Bugs Bunny, and assigning those to the first and second element in the array. This is not the case for an array of primitives, for example, with integers or doubles or booleans. Once I've allocated it, I can just assign an integer to that value. Now, if I already have an allocated object, then I can assign that allocated object to any particular array element. To iterate through the arrays, you're going to use the length attribute, which returns the number of elements in an array. So here's an example using a traditional for loop. For integer I equals 0, I less than grades.length, and then here we go grades sub I is going to get me each corresponding element out of that array, and we're summing those together. Of course, we can use our for each loop, and this is another way to iterate through an array. So this is very similar to working with an array list. Now, this next set of slides, what I want to look at is comparing arrays versus array lists. Please note that they're both random access linear structures. So linear means that we just have a line of them. Random access means that I can access any particular element at any time. So I can access the 10th element, the first element, the 100th element directly just by giving that index into that list. Both of them have runtimes bound checking, and the size. Array is a fixed size once you have created and instantiated that array, and it cannot change. If you need to change the size of the array, what you have to do is make a whole new array and reinstantiate that. Whereas an array list, it's dynamic in nature, so the size can change over time by adding your add and remove methods, and it's going to grow automatically or diminish automatically as your program runs. Some other things to note on declaration and allocation. An array, we use the brackets. An array list, of course, is an object. We use a templatized type, so we have to pass in what type we have. In both of them, when we place objects in them, we have to use the new to make sure we have an instantiated object that we're placing in at that particular location. To access a particular element, for example, here to access the 5th element, we have here, we use the brackets to access elements within our array, whereas if we're working with an array list, we use the get, but the indexing into the array and the array list are identical. And then lastly, we have a comparison of going through and iterating using a traditional for loop. Again, note that there's a lot of similarities, except for arrays. The size is returned by the length attribute. The size for an array list is returned by the size method. To access an element within our array, we use the brackets and our index. To access an element within an array list, we use the get method. Very quickly, the last thing I want to touch on are 2D arrays. That is just an array of arrays. So you can think of it as a table with rows and columns. So we've got an example here. It's a 2D array. It stores color value for a grayscale image that is 320 by 240. So to declare a 2D array, we're adding a second dimension. So we use 2 sets of brackets here. So this is saying I'm declaring an array of arrays, a 2-dimensional array. If we wanted to go out to 3rd dimension, we would add another set of brackets here. We're just going to stick with the example of a 2D array. Then I come in here and go ahead and do my instantiation of the array. And I'm saying this is how many rows it has. This is how many columns it has. Then to access elements in here, the first index in here is specifying what row I'm accessing. The second set is accessing the column. So when I access 0 to 39, I'm accessing the last pixel of the first row. Where in this one, I'm saying go into image 319, 0 is saying I'm accessing the last pixel of the first column. The last example I've had here is iterating through a 2D array, and we use a nested loop, which is a loop within inside a loop. Here we're going to iterate through the number of rows, and in each row we're going to visit each column of that. So I've got for integer I equals 0, I less than image.length. This is going to return the number of rows that I have in my two-dimensional array, and this is working with that image array that was declared on the previous slide. And then for each row I'm at, I want to iterate through the number of columns. So I go to that row and I say how many columns are in this particular row. So the J indice is going to go through the number of columns. Then I come down here and say access ij. So what this is going to do is going to go to my first row, access the first, second, third, fourth, fifth, all the way through the row. Then it's going to drop out, come back up, increase I to 1. It goes down to my second row. Then it's going to access every single value in that second row. It drops out, comes up, I becomes 2, accesses every single value in that third row. So this is a way to iterate through a 2D array. So that's going to be it for this very quick lecture on arrays. The readings in the book provide a lot more detail should you need them.